talk to you about inverse functions. I'm a liar who lies. Well, yeah, I guess that's the title of the section. I really don't like that title, though. I think inverse of functions would be a better title. Ladies and gentlemen, from your investigations today in that fun, exciting activity you did, my definition of inverses is something like the following. Two functions are inverses of each other if and only if the operations of one function undo all the math of another function, leaving you with the original number you started with. Take a look at this. I've got two equations here, two functions. Y equals 3x minus 2 and y equals x plus 2 over 3. My question to you is, do they seem like they might be inverses of each other's? And why? Well, I'm going to do this in a couple of ways. The first thing is, I'm going to just test to see if it's an inverse. I'm going to pick some random number. Young lady in the back, give me a number.
4.
I'm going to plug 4 in for x in this first equation. I'll get y equals 3 times 4 minus 2, so y equals 12 minus 2, so y equals 10. Now, I'm going to take this 10, and I'm going to plug that back in to this second equation and see what the result is. When I do that, I get y equals 10 plus 2 over 3, which would be y equals 12 over 3, which is 4. Isn't this second equation's answer? Didn't the math in the second equation undo the math that this original equation did to get me back to the number that the young lady in the back started with, 4? Right? Well, wait a minute. Since this math undid since the math in this equation undid the math in this equation, I think they're inverses. Now, intuitively, if we think about why they would be inverses, we can also think about this in the way that the operations are performed. In this first function, would you agree the two math operations that we're going to be doing is multiplying whatever x I have by 3, so I multiply by 3 first, and then secondly, I subtract 2. Well, does it make sense that inverses should do the exact opposite of what I'm doing here? Hold on. Hey. Okay, so these are the two math operations I'm doing in this function, and I'm doing them in this order. Well, let's see. What are the two math operations I see here, and in what order? Well, this says the first thing I would do is add 2 to the x. And the second thing I'd do is I'd take that and divide by 3. Ladies and gentlemen, if you think about this, what's the opposite of multiply? Divide. What's the opposite of subtract? Add. And didn't they also switch the order in which we did them? I multiplied first, subtracted second. So I should add first and divide second if I'm doing the inverse. I hope that kind of makes sense on why we did that. All right? So if you're really kind of good at math and doing stuff in your head, if you gave me any linear equation, I could probably find the inverse pretty fast. Young lady in the back, give me a linear function in y equals mx plus b form. Slope intercept.
Y equals 4x plus 7.
I like it. Y equals 4x plus 7. So I see the two math operations that I'm doing in this function. I'm multiplying by 4 first, adding 7 second. So to find the inverse, does it make sense that to find the inverse of that, I would have to subtract 7 and divide by 4? Because aren't those the opposite of multiplying and adding? But shouldn't I do it in the opposite order? So shouldn't I go x minus 7 all over 4? Right? And I've just found the inverse. Clever, right? Okay, now, what if you have a more complicated equation, or you're just not seeing how to find the inverse the way we just described? Well, in algebra, because algebra is about taking something complicated and creating a quick, simple technique for it, here's how we do it in algebra. To find the inverse of a given function, the first thing you always do is just switch the letters x and y. Whatever the x value is, switch it with the y value. Now, if the function is in an equation, you do have to get y alone again. All right? All right. So let's take a look at what I'm talking about. In this example, I want to find the inverse of each function, and then I want to say whether the inverse is also function. But then I want you to state the domain and the range of each function and its inverse. Take a look at this first problem right here. Hello? Hey? Yes? I'm sorry, I can't hear you.
Goodbye.
I'm sorry, what?
Goodbye, Mr. Kong.
Goodbye. All right. So take a look at this. I've got a function over here. Why does this set of ordered pairs a function again? Because none of the x's in the domain repeat, right? So I know that that's a function. Now, how do I find the inverse? Well, according to this, I just switch the x values to the y values. Well, so my new function, the inverse, would simply be, instead of 1, 0, it would be 0, 1. 2, 1 becomes 1, 2, 0, 3, 0, 0, 3, and 2, 4 will be my last one. Folks, this is my inverse, okay? Now, is this inverse also going to be a function? No, it's not going to be a function because since the 0 repeats, this is not a function. Okay? Now, what's the domain of this function? Well, the domain of the original function, since the domain is my x values, since I have individual x values, I have individual domains. They'd be 1, 2, 3, and 4. My range are the individual y values, so my range would be 0, 1, and 2. All right, now for my inverse, what's his domain? Well, the domain of the inverse would just be 0, 1, and 2. And the range of my inverse would be 1, 2, 3, 4. Hey, wait a minute. By golly, do you notice that the domain of the first function becomes the range of the second function, and the range of the second function becomes the domain of the first function? Well, if you think about it, that makes total sense. Because didn't we say that to find the inverse of a function, you simply switch the x's and the y's? And what do we call all the x's of a function? The domain. And what do we call all the y's of a function? The range. So when you find the inverse, the domain and the range of him had better have switched with the domain and the range of your original function. Okay, great. Let's take a look now at another example where I'm finding the inverse of a function. All right, let's take a look here. I've got this example right here, y equals 3x plus 1. Okay? Well, according to my notes, to find the inverse of this function, I simply switch the letters x with the letter y. So I go x equals 3y plus 1. But now, I have to isolate the y again because, again, in an equation, you always want to get y alone to put it in what we call function form. All right, to do that, I would get x minus 1 equals 3y. Dividing both sides by 3, I get y equals x minus 1 over 3. And this is the inverse. To show inverse, we put a little negative exponent like that, y to the negative 1 power. Okay? And that means inverse. That does not mean take the reciprocal of y. All right? Okay. Now, what was the domain and the range of the original function? Well, since we know that this original function is a line, isn't this domain and range just all real numbers from negative infinity to positive infinity? Because we don't see any of those red flags of x's in denominators or x's inside of a radical, right? An even radical, okay? So the domain and the range is all real numbers. Well, again, if you look at this guy, in slope-intercept form, wouldn't this just be 1/3 x minus 1/3? So again, there are no x's in the denominator, there are no x's inside of an even radical, so I know that the domain of this guy would be negative infinity to positive infinity. So if you think about it, did my domain and range of the original function actually switch places? Absolutely. All right, let's do it one more time. And when I say one more time, let's do it 2 more times. All right, I'm going to go y equals x minus 8 squared. These guys switch places with each other, so my equation becomes x equals y minus 8 squared. But I got to get y alone. Well, luckily for us, there's only one y term in this problem, so he's sat mappable. to get this y alone, don't I just have to get rid of the squared and get rid of the 8? So I square root both sides. I get the square root of x equals y minus 8. What's my mistake? What's my mistake? Yeah, don't forget, when you introduce an even radical into an equation, you got to put plus minus there, right? And then adding the 8 across, you get y equals plus minus the square root of x, and then plus 8 at the end. And so this is my inverse function. Or, that's not a function. Folks, mucho importante. If you ever get a plus minus while finding the inverse, you know that this guy will not be a function, right? The inverse will not be a function. Remember that every function has an inverse, but not every inverse is a function. Okay? Well, one of the ways to tell is if you ever have to put plus minus in your answer. It's not going to be a function. Okay? All right, take a look at your domain and range. Now, for this first equation, but now this is going to go all the way back to chapter 4. And remember how you always say, do we have to remember stuff for the first semester? Is that going to be on our final? Well, here we go. Folks, this is chapter 4 work going all the way back into October. Isn't that first equation a parabola? Well, the domain of a parabola we know is all real numbers because there are no red flags. But the range will not be all real numbers. In fact, doesn't he go from the k value of the vertex to infinity? Or from negative infinity to the k value, depending on whether the parabola is smiling or frowning? Well, I know that this parabola is smiling since it's got a positive a value. So I know it's going to go from the k value, which is 0, to infinity. Okay? All right. Now, that's my domain and range. What will the domain and the range of my inverse be? Well, coming down here, I know that this guy's domain. Can I square root any number in here? No, because I've got that red flag. I know that, again, if I did my domain for him, it would be from 0 to infinity. And the range, if I look at my range, well, again, plugging in numbers for x and square rooting them and adding 8, and then multiplying by a positive, multiplying by a negative, you would find that the domain, the range with this guy would be negative infinity to positive infinity. Woe was me, woe was me. Notice, did my domain and range just switch places with each other? Later on, we'll talk about something called limiting my domain of my original function in order to produce an inverse, which is also a function. All right. Ladies and gentlemen, lastly, on this last problem, I'm going to get the inverse of this guy. First of all, I'm not a fan of the f of x notation when I'm finding inverses. So instead of f of x, I'm going to write y equals the square root of negative 2x plus 3. These two switch places with each other, so I get x equals square root of negative 2y plus 3. Now I get y alone. First thing I'm going to do is square square. I get x squared equals negative 2y plus 3. Subtracting the 3 across, I get x squared minus 3 equals negative 2y. And lastly, divided by negative 2, I get x squared minus 3 over negative 2, which becomes negative x squared plus 3 each over 2. Okay? And this is the inverse. Okay? The domain and range of the original function, well, this domain would be, well, again, if you did the math on there, your radicand can't be negative. It has to be either 0 or positive. So my radicand would be from negative infinity to 3 halves, including the 3 halves. And my range would be from 0 to infinity. Okay? On the inverse, his domain, if you think about it, would be from 0 to infinity. And his range would be from negative infinity to 3 halves, because it's frowning. And I'm actually a lying liar who lies. This guy's domain will not be that. It will actually be negative infinity to positive infinity because it's a parabola, which contradicts what I said earlier. We'll take a look at why this domain specifically is different from what it should be, knowing that they should switch places. We'll talk about that later.